Hey, fifth grade. So what we're going to do today is I'm going to kind of make you a video talking through this chapter with you like we would have in class, but we're not there, so we're going to do the best we can. So I'm on page C6 if you want to get in your book and follow along with me. I'm going to talk you through what you've been reading at home and what's going to be on your test on whatever day we have it. I forgot what day we have it, sorry. This one was pretty short. It wasn't too bad. I think most of you guys did pretty well on it. So on C6, we actually did start on this before we left school. You need to know that landforms are just physical features. You've been doing that for years in social studies and science, so you guys know that. Weathering. Okay, we need to know the difference between weathering, erosion, and deposition. Weathering is the process of it breaking down. So when wind and water come and they break things into tiny pieces called sediment, that's weathering. Erosion is when the wind picks it up and moves it. Deposition is when it gets to where it's going by the wind and it puts it down and it stays there. We talked about depositing in the bank. When you deposit a check in the bank, it stays there. So that's what that means. Before we left school, we did look at the floodplains and the delta that you see at the top, the Mississippi River Delta. This is where it all deposits when it comes down the river, so it's kind of the ending point. Okay, if you turn the page, they gave you wind and ice. We didn't get to this before we left school the last time we were together. So wind is another way that things can be weathered. So when you have something that is constantly being hit by wind, whether it be a beach or an area where they have sand dunes, it's going to constantly hit it and break it down. Then it's going to be moved as it's doing that, and then it'll be deposited somewhere new. Sand dunes are what you find at the beach. So when you're walking to the beach and you walk through that big pile of sand that's really soft sand, that's a dune. The wind has blown it there. Ice is another one. Glaciers. Glaciers are big and they're strong. There are two kinds of glaciers. Valley glaciers are in high mountain valleys, so hence the name valley glaciers. Then you have continental glaciers. Those are the kinds that you have in areas like Antarctica. Those are the ones you see on movies and TV and things like that. So you need to know that there's two kinds for that. Mass movement is when you have a whole bunch of earth moving at one time. So a landslide or a mudslide would be a good example of that. Creep is another type of mass movement, but it's slow. So think about creep. If you creep along somewhere, you're going pretty slow. Creep is when land moves a few centimeters a year and you don't really notice it until you start to see fences that are moved or poles or railroad tracks that have moved. Then you start to know that creep is happening. All right, if you turn over new landforms, so when all of this happens, weathering, erosion, deposition, new landforms are made. So if you look at the bottom, this is the Mississippi River south of Memphis, Tennessee. This is an oxbow lake, I think it's called. Let me see. I don't know if it tells you. Yes, oxbow lake. So old, slow-moving rivers form broad loops. So as the river's moving, it's making this broad loop. The loops become so broad they actually meet, so they kind of come together. Then it kind of cuts itself off and it makes this little U-shaped lake called an oxbow lake. If you look at the top, terminal moraines you also need to know. Glaciers are major forces for forming new landforms. As the glaciers of the last ice age moved forward, they pushed mounds of rock and soil in front of them. When the glaciers melted, they left behind at their lower ends long ridges of soil and rock called terminal moraines. Long Island and Cape Cod are terminal moraines. They mark the leading edge of the glacier that covered much of North America. So that is an example of new landforms. So you have terminal moraines, oxbow lakes, and some islands like Hawaii form that way. And if you turn over to C14, this is lesson 2. This one I think most of you guys remembered from last year. 3 layers of earth, crust, mantle, core. Everybody knows that part. Some of you on the work we did the other day couldn't really tell me the parts of the core. It has two parts, the outer core and the inner core. The inner core is solid iron, and the outer core is liquid, molten, I guess, metals. We live on plates. Those are upper crust, rigid pieces of land that float on the mantle. There's 12 of them in all, and they fit together like a puzzle. Let's see what else you need to know. They move a few centimeters a year. That's about how long your fingernails grow. They don't move very fast at all. They can move apart, they can move together, or they can move side by side. We did that last year in science. When they collide, they release energy. And that is when you get new landforms like mountains that form. When they pull apart, that's when you get volcanoes. And when they go side to side, you get earthquakes. You guys should know that from our earthquake unit last year. So if you flip over mountain formation, many of the highest mountains form where continental plates collide. As the plates push together, their edges crumple. So think of two plates pushing together and then crumpling up like this, and that's when you get your mountains. We've talked about this before, but the higher a mountain, the newer it is because it hasn't been worn down yet. I think you might have learned that in social studies too. Let's see. Mountains do not form only at the edges or boundaries of plates. Some of them form where the pressure from movement at the boundaries pushes a block of land upward. So it kind of goes like this and it pushes up. You can also have them where you have two plates that move like that. Volcanoes, you guys know that. Let me go over the difference between lava and magma with you guys, because some of you are missing that too on your questions. Magma is what it's called when it's deep inside Earth. Lava is what it's called when it reaches the surface and it starts to ooze out. Okay, so you need to know that difference. Chains of volcanoes form where a continental plate and an oceanic plate collide. The edge of the oceanic plate pushes under the edge of the continental plate. So it kind of does something like that. Mount St. Helens formed that way. We've gone over that one before in Washington. Some of them form in the middle of plates. So what happens is the magma gets really, really hot and it kind of shoots up in a column and then it explodes out and it makes a volcano. There are three types of volcano. Shield are broad ones and they're mostly lava. Cinder cone is mostly ash. And composite are the really steep ones that you see that are lava and ash. So it's called composite because it's both. If you turn the page and we look at earthquakes, it gives you the example of Anchorage, Alaska as a strong earthquake. That one was a 9.2 and it only really goes to a 10, so it's really strong. An earthquake is a shaking of the ground caused by the sudden release of energy in Earth's crust. So when they scrape together like that, they kind of get stuck on each other. And eventually they're going to have to move past each other. And when that happens, it kind of juts off like that. And the energy is released in the form of shaking with an earthquake. We have more than a million of them each year. If you look at the news, and I'll have to pull up the article for you guys, there was one a couple of days ago in the middle of the United States, and I can't remember exactly which state, but it was a pretty big one. I think it was a 5 or a 6. So they happen pretty often. We don't hear about all of them because some of them are so small that you don't feel them or they don't do any damage. When the crust breaks, it forms faults. That's where it moves. They send out waves. It's almost like a ripple. If you throw a rock into a pond and it ripples out, that's what the waves are like. They're called seismic waves, and they're recorded by a seismograph. Okay, so flip on over to C22. This is one that you worked on, I think yesterday or the day before. Continental drift. So continental drift is the theory of how the continents have moved ever since the continents have been here. 225 million years ago, all of the land on Earth was joined together in one supercontinent called Pangaea. So that many years ago, 225 million, they were all one piece of land. So all the continents on Earth, all 7 of them, were all one piece of land. Over time, they moved. So 200 million years ago, they broke up into Gondwana and what's the other one they gave you? Laurasia. So then from there, they broke up into smaller ones as well. They drift still today. It says the Atlantic Ocean is getting wider. So if you think about the Atlantic Ocean and it's getting wider, you have North America over here and Europe over here. So if they're getting pushed apart, it's going to be a farther travel from North America over to Europe. If you look at the bottom at Continental Drift, 200 million years ago, it shows you Laurasia and Gondwana. Gondwana, 100 million years ago, starts to break into smaller continents. And then today, it has what we have now. The rock record. So look at the rock record with me. The Grand Canyon is a good example of the rock record. So if you look at the Grand Canyon, you can see the layers in it. The bottom layers are going to be the oldest layers. Fossils there tell us about what it was like a long time ago. It can tell us what lived there, what those animals were like. Scientists also depend on the fact that some things will always be the same. Processes that produced features like the Grand Canyon are still occurring today. So what made the Grand Canyon was the Colorado River. As it flows, the water constantly breaks pieces down and breaks pieces down. And so it was breaking it down further and further. So when you're standing at the top of the rim, you're looking down to rock that's 250 million years old. So that's older than what we just looked at with Pangaea. So this was around before they even split up with Pangaea. So if you are standing at the top of the Grand Canyon, that means about 250 million years ago, that's where the water once was. And the water now is all the way at the bottom of the canyon because that's how far it's worn down. All right, if you turn over how fossils show changes, fossils show us that life on Earth has not always been the same as it is now. Dinosaurs once roamed the Earth, as did large elephant-like animals called woolly mammoths. Scientists have drawn conclusions about these creatures from what they left behind. Whole mammoths frozen in ice and fossilized bones and teeth of dinosaurs. So if you look to the side as South America and Africa, this is a question you're going to have on your test and a question that you're going to have from here on out pretty much. Similar rock layers and similar fossils, such as the mesosaur shown below, have been found in both South America and Africa. This provides evidence that the continents may have once been joined together. So if you look at the continents as they are now, they look like they fit together like puzzles, and that's evidence of Pangaea being real. Another piece of evidence of Pangaea being real is something like this. This mesosaur fossil, the exact same animal and fossil, was found in South America and Africa. There's no way it could have gotten back and forth. This is a time before boats, before anything. So the only reason it could be there is if those two things used to be together. And then when they separated, the fossils stayed on either side. So you need to know that for your test. So that's the end of the 3 lessons. So what I'm going to do is pull out your test, and I want to go over some stuff with you. Some of the stuff I wrote on your study guide, I couldn't really write. I couldn't draw some of it because I just couldn't draw it on that document. So I'm going to pull it up and see if I can show you guys. So first thing, you need to know your vocab. I'm going to read you the vocab words that are on here. Continental drift, mantle, fault, fossils, erosion, magma, mass movement, deposition, plate, volcano, core, crust, Pangaea, landform, earthquake, and weathering. So you need to know all those, and it's just a little matching piece. Then what you need to know, and I'll take a picture of this and try to put it in with this video so you can see. It's going to give you 3 pictures. One was where it's raining, and in the background is a factory. So this shows us acid rain is breaking some rocks down. The other one it shows is a waterfall constantly hitting on rock, causing it to break apart. These are all weathering. And the last one shows rain coming down with a thermometer, showing that it's cold. When water freezes, it expands. If I leave a Diet Coke in the freezer too long, it's going to expand and it's going to bust open. So if we have cracks in the rock, then the water gets in, freezes, and expands and breaks apart. Another one you need to know is it's going to give you 5 pictures. It's going to give you plates going up like this, plates going like this, plates going apart with land coming up in between. You're going to go glacier moving this way, and plates moving this way with a volcano coming out. All of those form mountains except for the glacier receding, and I'll post a picture of that. You need to know that when two plates go like this, that is how the highest mountains are formed, and the Himalayas are an example of those. Let me see. For the other parts of it, it's going to ask you why footprints made on the moon would last for hundreds of years. So when they first visited the moon and they walked on the moon, those footprints are still there. That's because there's no weathering. There's no rain, there's no wind, nothing to move those footprints. If you were to go outside right now and you were to make a footprint, tomorrow it probably wouldn't be there. The rain could come down and wash it away, wind, other animals, things like that. On the moon, there's none of that. You need to know the center of Earth is solid because of all the pressure. So all of the pressure on Earth is kind of building on the center part, so it makes it hard and solid. You need to know when we say that Earth's plates float, that they basically are floating on mantles. So think about something like a pool float where it floats on water. The plates are floating on that mantle because they're less dense. We talked about the Atlantic Ocean getting bigger. So what's happening is the plates are moving farther apart and is pushing them farther apart. And then that's pretty much it. So what we're going to do Monday is during our math Zoom lesson, after we finish that, I'll have you guys get your science stuff out and we'll look at that and see if you have any questions too. So if you guys have any questions, just let me know.